we found that the derivative of sine is cosine, and the derivative of cosine is minus sine. Well, the last one we kind of took as fact. We could go through and do the proof for it, but we're going to take it as fact right now. All right. So now we want to look at the derivative of tangent. And so for tangent, yes, we can use the limit definition and then go through some more pain and agony, or I can be clever. Remember that tangent of x I can write just as sine of x over cosine of x, right? Oh, and I know the derivatives for each one of these, and it's a quotient, and I know the quotient rule. Let's use the quotient rule. So the derivative is going to be low cosine of x, d high, so derivative of sine is cosine, minus high sine, d low minus cosine, or minus sine, sorry, all over low squared. Okie dokie. And then cosine, so that's cosine squared x minus, actually that's plus because the minus comes out, so I have plus sine squared x over cosine squared x, and then this is just equal to 1 plus sine squared x. That's actually what all my pre-calc students say, but you are more clever than that, and you're like, no, Professor Bright, you can't just reduce that. You have to simplify it further. Actually, the numerator is just 1, Pythagorean identity, and then you get cosine squared x. And we know 1 over cosine is the same as secant, so this is just secant squared x. So the derivative of tangent is secant squared. So now we found derivative of sine, or of sine, cosine, tangent, and then we would need to find the derivative of their reciprocal functions, which, again, reciprocal functions we could just use, or use the definition of the reciprocal function and then do the quotient rule for that. And doing so would yield the derivatives of cosecant, secant, and cotangent, which you can see in the nice little box on the right side of the box here. Okay, so these 6 derivatives are absolutely critical. Make sure you memorize them. And before we end this video, I want to point out one quick thing. If I look at sine, I'm curious what the 23rd derivative is. Why? Well, I'm just interested. If I take a look, y is equal to sine of x. I know y prime, the derivative is cosine x. Derivative of cosine, if I do that, the second derivative, that's negative sine. Oh, so I'm seeing, okay, doing 2 derivatives is just a negative. Third derivative, which would be the derivative of sine, is going to be minus cosine. Okay, so I'm seeing that negative pop up again, and then if I do the fourth derivative, actually I think they use regular old numbers in parentheses, the fourth derivative, that is just going to be derivative of cosine is minus sine, minus minus, end up with sine. So every 4 derivatives, at least sine and cosine, they repeat. So if I think about the 23rd, so that is 3 after 3 after a multiple of 4, the 23rd derivative should be the same as the third derivative of y, which is just going to be minus cosine. Okay, so make use of this fact whenever you can. It could make your life a lot easier.